I'm probably going to have to spread this across 2 slides because this doesn't leave me with very much room to work with. But going through and bugsing our question so that we know exactly what it is the question is asking us to do. Iron is more reactive than lead. Iron reacts with lead nitrate solution to form solid lead. 2 possible balanced equations to the reaction are below. So here we've got equation 1 and equation 2. In one experiment, it was found that 4.48 grams of iron reacted with excess lead nitrate to form 24.84 grams of lead. Okay, that's all going to be important information, so I'm underlining it. Remember our bugs: box, underline, glance, and scribble. Carry out a calculation, so there's our command. We're going to have to do some maths here using the information above to show which equation represents the reaction taking place. It gives us some relative atomic masses that are going to be helpful to us. So now I'm going to move on to the next slide, which is going to be a blank one, and I'm going to show you how I would lay this out. So my setup, the first thing I'm going to do is I'm going to write out this equation, or at least the parts of it. So iron is part of it, and we're going to be adding that to our lead nitrate. Oops, sorry, that's a 2, not a 3. And that's going to be going to FeNO3 2 plus Pb. That's our lead. So I've got my equation laid out. That's always going to be the first step in my mind, is getting those kind of written out so that I can then decide what I'm going to be putting into each column. So I'm going to split it into its columns for each chemical. Now the information we have, we're going to be using our mass of Mr. Mole table again. So it told us we had 4.48 grams of iron, and it told us that we made 24.84 grams of lead. So we don't have any information about these. Okay, so for now I'm going to ignore them. I'm going to cross those out. Next I'm going to use the information it gave us about MR. So for iron the MR was 56, and for lead it is 207. Now, just like before, we want to show the examiner what we're doing. So I'm not just going to do my division and write in a number. I'm going to show that I'm doing 4.48 divided by 56. And that's going to tell me the number of moles, which in this case is 0.08. I'm going to go over to the other side. And again, I'm going to show that I'm doing 24.84 divided by 207. And in this case, that comes out as 0.12. Now, just like before, I'm going to look for which one is smaller. So my 0.08 is the smaller of the two numbers, so I'm going to divide both by 0.08. And this is going to give me my ratio numbers. Now, in this case, I get a 1 on this side, and I get a 1.5 on this side. Now, when we're doing balancing equations, we don't use 1.5s, so I'm going to have to do a little adjustment here. So the easiest way to do that adjustment is to times this by 2 to turn it into 3. So now it's a whole number. Okay. If I do it on one side though, I have to do it to the other side. So I'm going to times this side by 2 as well. So now I've got a 2 to 3 ratio. So I know that I should end up with a big 2 in front here of my iron, and I should end up with a big 3 here in front of my lead. If I go back to the 2 options that we had for our question, we can then look and compare and see that equation number 2 has 2Fe plus 3 PbNO3 goes to 2FeNO3 and 3 Pb. So it's actually equation number 2 which is the correctly balanced equation. So I hope you found that useful, and please try at least a couple of other questions using the same technique to help really cement this idea of how to do it in your head. Thanks very much for watching, and I hope you found it useful.